concludes lesson 4.2. And in this lesson, we're going to take a look at triangles or figures that are similar. There are three ways to determine whether triangles are similar. And in number 2, what we notice is that we have one pair of angles that are congruent to each other. We have another pair of angles that are congruent to each other. So by the angle similarity postulate, we say that these two triangles are similar by angle. In number 4, we have one pair of corresponding angles that are congruent, and then we have two sides that correspond in the ratio of 3 to 9, and we have two other sides that correspond in the ratio of 2 to 6. Both of those ratios are 1 to 3. So we say that these two triangles are similar by side, angle, side. So we have one pair of sides that are proportional. We have another pair of sides with the same ratio of 1 to 3. And then we have a pair of corresponding angles that are sandwiched in between the two pair of sides. So this angle that's 60 degrees is in between these two sides. This angle in between these two sides. So it always has to be the angle that is included between the two sides that have the same ratio. Question number 6, we need to find the value of x. So we need an equation that can help me to find the value of x. Before I determine that equation, I need to decide if these two triangles are similar to one another. Because we have parallel lines with a transversal, we can now conclude that angle A and angle E are congruent since they are alternate interior angles. And these two angles are vertical angles. So by the angle similarity postulate, we can now say that these two triangles are similar to one another. Knowing that the triangles are similar, we can write a proportion to help me to find x. This side 5 corresponds with this side 10. This side 2x plus 5 corresponds with this side 11x minus 4. So to find x, I'm going to solve this proportion. To do that, I'm going to cross multiply. for number 8, or at the top of the page, it says determine whether each pair of triangles is similar and explain your reasoning. Another way to prove triangles are similar is to see if the three sides are proportional. So if I want to match up sides in the large triangle with the small triangle, I'm going to begin with the smallest length in triangle ABC, and I'm going to match up that side length with the smallest length, or the shortest length, in triangle KLJ. The largest, or the longest side in triangle ABC is 16, which corresponds with the longest side, 12, which leaves 12 corresponding to 9. Since all three have the same ratio of 4/3, then we say that the triangles are similar by side, side, side. Side, side, side similarity. So you'll notice I started by placing all the vertical angles, and I want to make sure I include that one. And I'm going to look for all the supplementary angles. In this green triangle, I know 2 of the interior angles. I know one of the angles is 60 degrees. I know one of the angles is 70 degrees. And I can find this remaining third angle by subtracting those 2 from 180. So 180 minus 130 is 50 degrees. Now I can determine the measure of this angle. Which now tells me this angle. And then I'm going to find the measure of this missing angle. So one of the angles is 90 degrees in that triangle and 33 degrees, which leaves this angle as being 57 degrees. now I can come down and find the measure of this missing angle. And let me highlight the triangle that I'm looking at right now. So in this triangle, I'm missing one angle. So I can find that missing angle. One of the angles is 83 degrees. The other one is 57, which leaves me with 40 degrees. These two angles are supplementary. Another pair of vertical angles. Here's another pair of vertical angles here. So to find the measure of this missing angle, I know two of the angles in that triangle are 50 and 88. It looks like I have all those angles there. There's a few up here, like this one would also be 57 degrees, and then we can find the supplement of that right here also. It's an angle that's 130 degrees.